This video is designed to give you some practice with scientific and engineering notation. Please pause the video and put these 5 numbers in scientific notation, and when you are finished, you can restart the video. In scientific notation, we want one non-zero digit to the left of the decimal place. So for number 1, that digit will be a 6. So we'll have 6.75 times 10. And to figure out what the exponent is, we determine how many places we need to move the decimal in order to get it to be right behind the 6. So it starts right here, and we're going to move it 1, 2, 3, 4 places. We're moving the decimal to the right. So this is going to be a negative exponent. And remember, we want to multiply 6.75 by a small number in order to get a small number. So you know you're multiplying it by a negative exponent. For number 2, the one non-zero digit in front of the decimal will be a 4. So we'll have 4.56 times 10. Here's where the decimal starts, and we need to count how many places we move it in order to get it right behind the 4. So we're going to move it 1, 2, 3, 4, 5, 6, 7, 8 places. So the exponent will be 8. And in this case, it will be positive because we are moving the exponent to the left. And again, we want to multiply 4.56 by a large number in order to get a large number. For number 3, the one digit that's not 0 in front of the decimal place will be a 3, so we'll have 3.09 times 10, and we're moving the decimal from here 1, 2, 3, 4 places, and it will be positive because this is a big number and we're moving the decimal to the left. Number 4, we're going to move the decimal right behind that 7. So only the 7 will be in front of the decimal or to the left of the decimal. We'll have 7.12 times 10, and in this case we're going to move that decimal 2 places. And it will be negative because we're moving the decimal to the right and we have a small number. And number 5, the non-zero digit in front of the decimal will be a 1, so we have 1.34 times 10. We see how many places we move that decimal. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 places. And it will be positive. This is a big number. We're moving the decimal to the left, so we're going to multiply it by a large number. Now pause the video again and put these 5 numbers in scientific notation. Remember, only one non-zero digit to the left of the decimal. Restart the video when you are finished. Here are the answers to check your work. If you are still having trouble with scientific notation, you may want to go back and review the video on scientific and engineering notation. Now I want you to pause the video again and put these 5 numbers in engineering notation. And when you have finished, restart the video. Now remember, in engineering notation, the key is that the exponent needs to be a multiple of 3. So for number 1, we need to move the decimal place from behind the 0 to the left so that we have either 1, 2, or 3 digits to the left of the decimal, and the exponent is a multiple of 3. So if I move the decimal 3 places, I still have 4 digits in front of the decimal. So I'm going to move it another 3 places, and now I only have 1 digit in front of the decimal. So this is where I want my decimal to be. So it's going to be 4.602 times 10. And how many places did I move it? I moved it 1, 2, 3, 4, 5, 6. I moved the decimal to the left, so this is going to be a positive exponent, which makes sense again because this is a big number, so I want to multiply 4.602 times a large number in order to get this. For number 2, I start with my decimal here. Okay, I'm going to move it in groups of 3, so 1, 2, 3. I do not have a non-zero number in front of the decimal if I stop there, so I'm going to move it another 3 spaces or places, 1, 2, 3. So if I move my decimal here, I would have 3 non-zero digits in front of the decimal. Remember, I needed a number between 1 and 999 inclusive. Well, 781 is between there. So I would have 781 times 10. And how many places did I move it? I started the decimal here. It went 1, 2, 3, 4, 5, 6. And in this case, it will be a negative exponent because I moved my exponent to the right and I'm multiplying 781 by a small number in order to get a number less than 1. For number 3, I start with my decimal after the 0. I'm going to move it in groups of 3, so the first one is 1, 2, 3, and I will be left with 3 digits in front of the decimal if it stopped there. Well, that's correct. I went 304. If I were to move it another 3, I would have no non-zero digits in front of the decimal, so that's not correct. I'm only going to move it 3 places, so it's 304 times 10, and in this case it'll be 3. That's how many decimals I moved it, places I moved it, and it will be positive because I have moved the decimal to the left. In the fourth one, my decimal starts here. Let's see if I move it 1, 2, 3. I don't have a number between 1 and 999 yet, so I go another 1, 2, 3. I still don't, so I'll go another 1, 2, 3, and now I will have 67 to the left of the decimal, so that would be 67 times 10, and I need to go back and figure out how many places I moved it. I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, and the exponent will be negative because I moved my decimal to the right, and I'm multiplying 67 by a very small number in order to get a very small number. Number 5, my decimal starts after that last 0. I'm going to move it in groups of 3, so 1, 2, 3, 4, 5, 6, 7, 8, 9. When I move it 9 places, I'm left with just a 1 in front of the decimal. And remember, I need something between 1 and 999 inclusive, so 1 will work. So 1 times 10, and I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9 places, and I moved it to the left. It's positive because I want to multiply it by a really big number. Pause the video one more time and put these 5 numbers in engineering notation. Remember that the exponent needs to be a multiple of 3. Here are these 5 numbers written in engineering notation. If you are not getting these right, please go back and re-watch the video on scientific and engineering notation, and/or come and see your instructor for extra help.